As you can see, this is the code we wrote last time, and this was what we used before, just for the simple purpose of receiving and storing data. Let's save this under a different name for the time being, and I will safely store it as PM 2008 packet logger right here. I will save it as that. I saved it under a different name, and in this state, processing can also add files in a new tab. As you know, considering that we are writing a program in Java, which is a popular programming language, we will call it Packet Java. In this state, I will carefully create another class like this, and then I will appropriately create a packet class in this way to generate a packet instance. I will then insert the corresponding values into the buffer and call the command so that it can be verified, or simply create that instance and use the command which we have already done on the Arduino side. We will organize and implement commands that automatically generate packets to be sent to the Arduino by inputting commands like get PM2800 or data as parameters. First, let's organize the constants. Here, we have packet-related items such as STX, ETEX, CMD, and POS. Let me provide a brief summary of these important points for your reference. It is important to note that Java does indeed have a byte data type. However, it is crucial to understand that this byte is signed, which means it has a range from 128 to 127. So I can't exactly put in 2 and 56. Therefore, for now, I have no choice but to use an int. The terms tick, final, int, hacking, tx, and comments are essential in our system. Tick is the clock signal, final marks the end stage, int means interrupt, hacking is unauthorized access, tx stands for transmission, and comments are notes. These elements, tick, final, and int, are now part of the process. Regarding the position, there is only the LAN command data related to the location available at this time. However, for now, I will also include the STX to ensure completeness and accuracy in the data transmission process. Next, here we will use a variable buffer to efficiently manage data. You can think of it as an array structure, which is a way of organizing data in a linear format, allowing for efficient access and modification. Here, we write it like import Java, util, array list, which is a part of the Java collections framework, providing us with a resizable array implementation. We then proceed to set up the buffer, which acts as a temporary storage area, and add a member variable to hold specific data values. Then we create a constructor that is intentionally left empty so it can be called without any initial parameters, allowing for flexibility in object creation. After that, if we use a constructor to insert data received from the Arduino for verification purposes, we can do it this way, ensuring that the data is correctly formatted and validated. Since the buffer will obviously be empty during the initial constructor call, there is no need to reset the buffer. We can directly add the data, which simplifies the process and reduces overhead. In case The packet functionality is enhanced. Later, it might be used frequently. So let's create a command related to clear and keep it private. Now, regarding the generate command, in C language, it receives both command and data. The reason for receiving these two is that with just the pointer, we cannot determine the length of this array. So, we receive the rank, which is an important part of our process, and here we have a method called public void generate, which takes two parameters, an integer command and an integer data. Initially, we reset everything to ensure a clean start, and then we put in the start of text, abbreviated as stix. This is a crucial step because it sets the stage for what follows. When the rank appears, it triggers a sequence of events. We have several components that come into play: the command, the data, the control signal, the end of transmission signal, and finally, the rank itself. These are the 5 key elements that we work with in this process. In the original scenario, the rank is set to 2. This is a predefined value that helps us manage the flow of information. If the data happens to be 0, then the situation changes slightly. In this case, only the control signal and the end of transmission signal are included. This is a natural outcome of the process, and as a result, the rank remains 2. This means that the buffer will add the data length plus 2, ensuring that everything is accounted for and processed correctly. This detailed explanation helps us understand the intricacies of the system and ensures that we are all on the same page regarding how the rank and data interact within the framework of our operation. The process starts when it enters this section, which is important for the operation. Next, the buffer add command length is inserted here, allowing the system to process the information correctly. Finally, the procedure ends with a clear action that marks the end of this sequence, ensuring no further operations are needed. This approach ensures clarity and precision in executing the task, maintaining the process's integrity from start to finish. I made a mistake, which was more significant than I initially realized. It happened during an important project when I overlooked a crucial detail. This taught me the importance of being thorough and attentive. The command sequence and subsystem ran along with the command itself, control signal, and end of text. These total 3 in number, so it's indeed a count of 3 in total. Therefore, within our data, rank, system framework, we add precisely these 3 to enhance our rank metric value. Then subsequently insert this specific command set into operation mode, followed meticulously by database data repository entries, systematically integrating all relevant data sets into application processes, and finally executing through an established control signal. Since the control signal, CS, is not included anyway, we can put everything in the buffer. It can all be cycled through, so we can include the control signal and the end of transmission signal, BTX. The process begins with the insert operation, which is a crucial step that completes the overall generate function. This function is responsible for creating and organizing the necessary data structures required for the subsequent operations. Once the generate function is successfully completed, we proceed to perform a public check. This check is an essential verification step that ensures all operations have been executed correctly and that the data integrity is maintained. After confirming that everything is in order, we return a true value, indicating the successful completion of the process. Following this, our attention shifts to the next task, which involves checking the STX. This step is vital for ensuring that the syntax and structure of the data are correct and meet the required standards. Please ensure that you verify thoroughly if the buffer gets the host start of text, STX, and whether the packet start of text, STX, matches precisely, as well as confirming accurately at all times regarding end of text, ETX. The last element is crucial in determining whether the current state is BTS or if it transitions into the next verse. Following this determination, a comprehensive LAN check is essential to ensure proper functionality. In the event that the offer successfully receives a packet, it is imperative that the LAN +2 aligns precisely with the offer size. Failure to do so results in a false return. This discrepancy arises because the LAN inherently excludes the 2 bytes allocated for SX and LAN. Consequently, the value of LAN +2 must correspond exactly to the actual total length of the buffer. Any deviation from this expected value will result in a false outcome. Next, with the switch, you have the option to include this or not, depending on your specific needs and preferences. The reason for setting it up in this particular way, even though we currently have the configuration set to packet, false, CNG, is to ensure that we are prepared for any potential changes or increases in the number of commands that may occur in the future. By anticipating these possibilities, I have proactively set it up in advance to accommodate such changes. In the subsequent step, the checksum, which is essential for verifying data integrity, is being copied. However, it's important to note that only the final segment of this checksum is being processed, and this specific part is referred to as a MAC. This designation helps distinguish it from other sections of the checksum. Additionally, the variable int_cs indicates the size of this segment. It's crucial to mention that this size has been converted into an integer data type, a common practice in programming to ensure accurate calculations and efficient data handling. This conversion is vital for the operations that will follow on this data. If the checksum does not match, it should return false. I mentioned this during the Arduino discussion as well, but if you want to do precise and accurate debugging, it would be good to print out messages like STX does not match or ETS does not match here, which is crucial and essential for accurate debugging. For now, let's move on. Next, we have the data rank and the command left. These are determined by the data rank size, which includes STX, ETX, CMD, checksum, and the subtraction of O, resulting in the data size. Additional details can be considered to ensure clarity and understanding. Public int get command, method, return buffer, get packet is seamed, then let us indeed proceed with this by interleaving, since it seems like we'll be using get data often, let's just call it once in advance and put it in the training. The link provided here is specifically designed to retrieve data from a particular source. This process is crucial for ensuring that the necessary information is gathered efficiently. In the event that the data length is determined to be 0, the system is programmed to immediately send an empty array. This is followed by sending the data length, which is a critical step in the process. Subsequently, the variable I is assigned the value of the data length. The operation I plus result is a key part of the function, where I is used in the buffer GAN-kit QST operation. This ensures that the data is processed correctly. Finally, I will return the result, which is the culmination of the entire process. Let's proceed to build it once. ensuring that all steps are followed meticulously to achieve the desired outcome. Then there definitely won't be any errors. Currently, the port is not connected, which is the main reason for this issue. When the port is disconnected, the system cannot establish a proper communication channel, leading to potential errors. For example, if later the system tries to execute a command and output something like packet new packet generate kit cmd get pm6068, it shows the system is processing commands without a stable connection. This lack of connection can cause the system to fail in verifying or validating commands, resulting in errors. In a connected state, the system would process these commands smoothly, ensuring correct execution. Without the connection, the system operates in a vacuum, unable to confirm command success or failure. This highlights the importance of ensuring the port is connected to avoid such issues. Regularly checking the connection status is crucial to prevent unexpected errors. The error here is because it's not being sent to the port right now. I've set it up in such a way that you can create a class and instantiate it to generate, or conversely, when you receive a buffer later. It will be created here and immediately inserted, and then you can check the package. This is how I've structured it for now. Regarding this part, I will first upload the code and then include a video, explanation of the gist, shortcut code below. This time capture processing, which acts like a packet library on the Arduino side. At that time, the uncle wrote the code for the package class. Next time, we will implement the actual communication between Arduino and processing, check the packets, and save them to CSV.